In this video, we'll be going over how to calculate the average atomic mass of strontium. Let's go ahead and get started and read this problem. Calculate the average atomic mass of strontium. The first thing we do, or the first thing I notice when I see this problem is notice that we are provided with two different sets of values. We are provided with the 4 different naturally occurring isotopes of strontium here, and their corresponding percent abundances here. And so really, the first thing you want to do is just sort of try to understand what these percent abundances mean. And this is what they mean. So, like 82.58% of the time, strontium-88 is found in nature. 0.56% of the time, strontium-84 is found in nature. And so on and so forth for these other two values here. And so that's really what they're indicative of. And that really just helps explain a little bit why, when you're calculating the average atomic mass of an element here, which in this case is strontium, we don't calculate the average in this manner. Look, we don't do it like this. I repeat, we do not do it like this. Do not do it like this. This is incorrect. So although this is a correct way to calculate an average in your typical math class or almost on an everyday basis, when you're calculating the average atomic mass, it's incorrect. We don't do that. This is incorrect. And we don't really do that because it's just, look, it's not fair. 82.58% of the time, 82.58% of the time, strontium-88 is found. Opposed to 0.56% of the time, strontium-84 is found. So strontium-88 is found significantly way more than strontium-84 in nature, and so just for that reason, it's not really appropriate to calculate an average in that way, because when you calculate the average in that manner, what you're really saying is that strontium-84 has the same weight as strontium-88. It has the same number of chances of appearing in nature, right? And that's not really the case, because these percent abundances indicate otherwise. And so what we do when we're approaching these problems is we calculate the average atomic mass, calculating a weighted average. We calculate a weighted average, and this is how we find our average atomic mass. And the setup for calculating a weighted average is like this, look. I'm just color coding these so that you guys can better understand, or that so they could just appear a little more clear to you guys. So look, this is a setup here for the average atomic mass calculation, which is a weighted average calculation. This is how we set it up when we're calculating a weighted average. Really, all that you're doing here is multiplying the masses of each of the different naturally occurring isotopes of strontium and multiplying them by their corresponding percent abundances, if you haven't noticed, right? So this is really the same percent abundance next to each of the different masses of the 4 naturally occurring isotopes of strontium. And so all that you do is multiply them by each other, and then after you multiply them, you really just add each of these products up. You calculate the sum of each of these products, and that provides you with your average atomic mass. So we're going to calculate this right now. But really quickly, before we do calculate this, I want to just point out that one thing that you really do need to pay attention to is how you insert these percentages into your problem setup, right? I inserted these percent abundances in their percentage form, right? I inserted 82.58%, 7% here, 9.86%, and 0.56%, right? And so we know that we cannot multiply by percentages we usually first convert percentages into their decimal form and then go ahead and calculate problems. In this case, you can either insert every percent abundance as a percentage, and then the only thing you would do is in the end divide your answer by 100, and this would provide you with the correct answer. However, if you don't want to insert them as percentages and you want to go ahead and insert them as decimals, what you need to do first is divide each of these percent abundances by 100, and then go ahead and insert them into this weighted average setup down here. The only discrepancy is that you would not be dividing by 100 in the end. And so in this case, I am going to actually be leaving them as percentages in my problem setup and then just be dividing by 100 in the end. And so I'm going to go ahead and do that and just calculate this problem. You should get the same answer if you do it the other way. So there's really just two ways to approach this weighted average setup, but you should get the same answer always. Oh, sorry. This is 609 right here. So these are the 4 different products for these 4 different multiplication sets. And then the answer that you get is, or should be, 8,771.06. Now remember, I did not divide by 100 yet. So I need to divide by 100. So this is not the completed answer yet. And so after you divide by 100, you do get your accurate answer, and you should be getting 87.71 as your final answer, which in this case is our average atomic mass of strontium. And so this is how you calculate an average atomic mass, and I hope you understood how to do it. Until next time.